Hey everyone, it's Jad here. Today we're tackling the LeetCode problem, top k frequent elements. I'll walk you through how I'd solve this in a coding interview, from understanding the problem statement and devising a plan to coding, testing for errors, and evaluating time and space complexity. I'll be solving this in Python and I'll think out loud and ask clarifying questions just like in a real interview scenario. Let's get started. So first of all, I'll start by understanding the problem by going through the problem statement. So I'm given an integer array nums and an integer k, and we want to return the k most frequent elements. And we may return the answer in any order. Okay. Let's first try to go. So if I reformulate the problem statement, so given two things. The first one is an integer array, so nums, and k is an integer, and k corresponds to the most frequent elements in there. So in nums, we know that we will have duplicates, and we want to count those duplicates and rank them according to the number of occurrences, and choose the best k, the ones who appear the most, from the first one to second to k. And so I do have a few questions here. Can nums be empty? Because if it is empty, well, I mean, is it a problem? Yes, it is a problem. If k is anything else than 0, we would still return an empty list, right? Because we do not find any of those elements. The second thing is, can k be bigger than let's say k is something like, 10, and the number of unique elements in nums is only 3. Well, even if k is given, we could not, we can't, provide k elements in the list, right? Is that a problem? Well, not really, but if we look into the constraints here, we know that k is in the range of 1 and the number of unique elements in the array, so it's already, we already make sure that k is valid. That's one thing, and yeah, nums can be negative or positive, that's not a problem there. And yeah, we at least have one element in nums, so we do not have to take care of nums being empty. So yeah, let's go through this first example here. So if I write this down, what can I do? So one thing that we can see here, we can note here, is that the nums is sorted. So if it is sorted, well, it is pretty simple. I just have to count. Counting the elements is pretty simple because, I can just have a counter, iterate it +1 until we change. So we have 3 ones. No, this way 1 is 3, 2 is 2, and 3 is 1. And then we can just sort them sort keys according to values, and if we look this as a hash map, and we just return the ones we may return the answer in any order, so it doesn't make sense. And one thing to note is, let's say we have another 4 here. I mean, 2 4s, in which case we would end up with 4 2, right? And here we have to make a choice, because are we going to return 2 or 4? Well, this situation creates 2 different solutions to this problem. And if we look into the constraints, this is the input are given such as this will never happen, right? This will never happen. Okay, so I'm using a hash map here. And yes, so and sorting them according to the values. And I'm picking the first K, the numbers. The first K, yeah. K first keys. So this is my solution here. And if I look into this, I'm iterating over the nums to create this hash map. So it's O of n. Then I'm sorting them. I'm sorting the keys according to the values. If we had, in the worst case scenario, if we had only one if there were no duplicates, I mean, we would end up with n equal the number of keys equal to number of nums. So it's O of n log n, right, to sort this out. And then to pick the first k keys, we just have to slice the first part. So let's implement the solution here. I'm going to use collections to get the hash map immediately. That's going to be frequencies. And it's going to get nums in there. This creates the hash map as given here. Then what I do is I want to sort the keys according to. So what do I do here? I'm getting the keys from frequencies, right? And what am I doing? I'm sorting it given that key is X, that is the key, frequency X. So what am I doing here? I created a list of frequency keys. That is all the numbers, all the unique numbers appearing in nums. And then I'm sorting it according to their values. And the thing is, I want to have the opposite, right? So I can either use minus frequency to invert. Yeah, I can do that. I can do this. And this is going to be the sorted, unique, or maybe the candidates. Yep. This can be candidates, and I will store it as a list. And what I'm returning is candidates from 0 to k plus 1, right? And I do not have to check if k makes sense or not, because I know that the candidates are, the length of candidates is higher than k. So, it's k because it's from 0 to k minus 1. So it's k. And yeah, this works. Let me test this with the second example here. So if I do have this, what happens is I'm using counter to create this hash map. 1 is being 1 and k is 1. And then what happens is we are getting the frequency keys that gives me 1. Then I'm making it a list and sorting it out using its frequency. So it's not doing anything here. But if I had 1, 2, and minus 1, well, in this case, I would have, maybe I should have minus 1 twice. I would have this. And what happens here is, okay, I'm getting the keys 1 and minus 1, and frequency of 1 is 1, and frequency of minus 1 is 2, so it's minus 2. So minus 1 is being put before the 1. And why do I do this? Because I want to get the first k. So it's between 0 and 1. And so only the first one is picked. That is minus 1. So yeah, this should work. Let me run this. There's a problem here. Oh, yeah. There should be a lambda. There we go. It worked. Let me submit this. Yes, so it worked. And now let me go through the time and space complexity for this problem. For the space complexity, at least, it's pretty simple. In the worst case scenario, we would have O of n, because we are actually, creating a new hash map for this one. And also we are recreating a list that is sorted. And because we're sorting the list, it's O n log n. This is O of n. And this is the only one that gets O n log n. So yeah. Now, if I think about this, we can see here that we have a follow-up question. Your algorithm's time complexity must be better than O n log n, where n is the array size. So how could we do this? So it just means that we should not sort it. So how to improve this? to improve. No sorting. That's the solution. And how could I do this? So one way to do it is actually using heap, because we will not have n log n, but we will just keep the like, for example, let me go through this. So this is okay. I can do this because it's O of n. And once I do have these frequencies, what I would do is I would iterate over keys, and I would heap push yeah. Thinking about it. So if I use a heap here, so I do have the hash map, then what can I do? Well, I can push the results as such, where the value is put this way, maybe, because I want to arrange them according to this one, right? 3, 1, and I can do this because I know that there is no different numbers that have the same number of occurrences. So I can do this. So to note, important, frequency for each number is unique, given that it is guaranteed that the answer is unique, right? So I can push this way and 3, 1. Then what can I do? Then when I have 2, 2, for example, I know that if k is equal to 2, then I would still put this here, right? Then when I am inserting 1, 3, so at every single step I would check if length of this result is equal to k before inserting, I mean. For inserting, check if, the one in the top, maybe I should leave it the other way, right? It should not be this way. It should be the min heap. Why that? Because I'm checking if check if my new element that I'm inserting, that is frequency of new number, higher than the minimum one. So if I'm inserting 3, 1, so it's 1 here. Maybe let's just modify. Let's say that 3 appeared like 10 times. So it is, so I'm going to insert it. So I'm going to remove the if this is the case, pop the min and push this one, which is gonna not be inserted immediately here if it is 10, but at the right position, right? Yes. And right frequency of number higher than. So there are two things to check. Check if length of k and this one, and pop them in and push this one. I mean, I should maybe check this one in this order. So I'm checking if frequency of the new number higher than the minimum one, then and if len is, then we would pop it. But in all cases, so if they are both true, then we would pop and push. If length result is different from k, then we would push immediately. We do not care about this one. Push immediately because we haven't reached our k most frequent elements yet. And yeah, we just have to do this. And what's pretty cool with this one is to insert, it's not on log n, but it's ok log. I mean the overall. To insert it, it's o log k, and space complexity is the same, O of n. The time complexity, on the other hand, is pretty different. It's OK log. What am I doing here? So to insert it, it's log k. And I'm doing this for the n candidates. So it's on log k. That is better than n log n, right? Yep, that's it.